as we go into more and more of these things, we have to understand how just redrawing problems over and over and over again. Guys, stop eating the food, please. Put it away. Okay. Thank you. So when you have these big picture style problems that have multiple sides, multiple parts going to it, you basically pick one spot and you work your way out of it. You're going to start to see more of this style problem as we go forward with the trig, with the, we get into polygons and stuff like that as well. So in this case here, you know that the figure on the left is a what?
Triangle.
Correct. I'm looking at my left. So the figure on the right is a
Square.
Square. Okay. So we have a square, which means that all of these sides are going to be 6s. So now we have a 30, 60, 90. Opposite this, opposite this, opposite this, x square root 3, and 2x. Across from which side do you know the side length? 60. So I set the x root 3 side equal to 6. And I solve for x. Bless you. When I solve for x, it gives me that multiple, gives me that value of x that is repeated through the other sides. So in your calculator, you just divide by the square root of 3. When you do that, you should get 2 root 3, if I'm not mistaken. All right? Okay. That is the value of x that gets substituted into here. So that means across from the 30 is 2 root 3. It's the value of x that gets substituted in here. So you get 2 times 2 root 3, which gives you 4 root 3 for across from the 90. You're finding that multiple, you're finding that scalar, if you will, of what's being multiplied across everything. And that's how that one works. All right? Does that make sense? Mm-hmm. 20, same basic principle. But they're hiding the triangles in there on you. So the triangle on the right, just the small triangle, you've got the right angle, the 30-degree angle, which makes this angle here how much? Good. Which makes this angle on this side 45. The 45. So what they've done here is they've melted together a 30, 60, 90 next to a 45, 45, 90. And they just have that reflexive side shared. So we know we start with the 30, 60, 90. Writing out our stuff. And across from which side of the 30, 60, 90 do we know?
The 90.
The 90. We know that the 2x value has to equal 16. Well, what has to be the value of x to make it what? 8. Very good. We divide both sides by 2. So now I know that the value of the multiplier is 8, so that value of x is going to go here and here. So that means across from the 30 is 8, and across from the 60 will be 8 root 3. So I fill that in. So I have an 8 here, and I have an 8 root 3 here. And now I look at my 45, 45, 90. Yes, ma'am?
When you have like the 30, 60, 90,
yeah.
For the 60, when do you know to divide it by the root 3?
When you are given it across from the 60. Okay. Just like in the 90, if you're given it across from the 90, you'd have to divide it by 2. So the next set, we have the 45, 45, 90, and we know opposite the 45, so we just write it out. We know that opposite it is 8, which means opposite the other one is 8, which means opposite the 90 is
8 root 2.
8 root 2. Does that clear those two up? Cool. What else do you want to look at? Which one? 12? Now remember, what this is actually saying is find the missing side lengths. So these, you don't really think of it as x's and y's. You're finding the missing side lengths. So in this triangle, we know that it's what type?
30, 60, 90.
30, 60, 90. So we start with it, writing it out. Across from which one of those do we know?
60.
So across from the 60 is equal to 13 square root of 3. So I have to solve that one-step equation to figure out what the multiplier is. Well, when you take 13 root 3 and divide it by root 3, you get
13.
13. Very good. So I take this then, and I substitute here. And I substitute here, and I get 2 times 13, which is, and those are my two other side lengths. 26, 13. Okay. I should do 16.
16 was pretty easy.
What kind of triangle was it?
30, 60, 90.
Good. I wanted to make sure you guys recognize that it being a 30, 60, 90. I was hoping you'd figure that out.
And then 2 times that.
I thought that I just realized that they're using N. I thought it was just like an R and a weird I.
Oh, I got you. Does everybody see how that's got to be a 30, 60?
Yeah, when I saw it, I was like,
It just looked.
I was like, oh.
Yeah. They're kind of sneaky every once in a while. You don't have to solve, obviously you're not solving for N or anything like that. They'll throw that at you and make you think about what does it have to be. So this one here, just for giggles, since we have it up. Across from which one of those do we know?
The
90.
30.
Yeah. Yes, it is 30 across from the, there it is.
Wait.
Very
it's
good.
wrong problem.
There you go. Okay. I know we didn't have to do 19. Well, let's take a look at it.
Wait, wait.
Yeah, we did.
Yeah.
Oh, that's right, we did. I'm sorry. I
I
was
had to do
thinking
all for the back page.
Wait, what?
15 through 20. All.
She's so quiet. She's get it together, Murphy. You
Accidentally did the odds anyway.
Oh.
Same.
Okay, so 19.
What
What kind of triangles are these? These are all 45, 45, 90s, which means that you have a square. Across from which angle do you know?
90.
90, very good.
He's right, I guess.
I know that across from the 90 is going to be some value x times the square root of 2 to equal my side length, which means I have to divide both sides by. Very good. So I'm going to get 12 root 2 for my missing side lengths.
It looks with the root 3s as well.
And that calculator is great.
I like my cheat code.
Yeah, I like his cheat code.
Oh yeah, you're cut it in half, slap root 2. Nothing wrong with that. That's good. I'm glad you
It's
figured.
really fast. Too.
I know it is, and that's essentially what I'd love everybody to be able to go, oh yeah, but it's no big deal. No, it's great. Yes, ma'am.
Can you do number 6?
Do you have $?
The only time that doesn't really work is it's weird.
I have butterscotch.
And then you have to just write it out. It's 24
No, thank you.
2 divided by 2.
Number 6. First of all, what kind of triangle is it?
The isos 45, 45. Wait, which one are we on? 6, yeah. 45, 45, 90.
So we know it's going to be a 45, 45, 90. So we start by writing out our jig. Across from what side, or across from which angle do you know?
90.
The 90. So I know across from the 90 has to equal 5 root 2. So I solve for x. divide by root 2. The value of x is 5. And then you substitute that back into both of these. We're going to ask? No, go ahead, really.
I thought you had to multiply the 5 root 2 and the root 2.
Oh, I see.
You know how you like,
Yeah. Remember, a lot of times, whenever the way that, and you're not the only one that does this same thing here. When you have one of your patterns here, depending upon which one you know, you're setting up a one-step equation to figure out what this scalar is. Okay. Now, it's great if you know that this is just equal to 7, because then this is 7 and this would be 7 root 2, is you're substituting in. What happens a lot of times is that you're just going to find out that across from one of the ones that has the radical is some other value, even if it is that. That just means that there's some multiple times the square root of 2 that got you the 10 root 2. So this is just a one-step equation of getting rid of the root. Okay. Also, it works the same way as if this was a 13. There's still an embedded root 2 being multiplied in, you just don't see it. What happens here is the same process. Something times the square root of 2 equaled 13. Well, what was that something? I divide it out. The calculator then does this for you. It rationalizes the denominator. Do you guys remember what that meant, rationalize? Remember that from last year? What that means is that it is an improper way to leave your answers with a radical, a square root symbol, in a denominator. It is not proper math etiquette. It's kind of like when you're at a fancy restaurant and you start eating with the furthest outside fork and work your way in. If you don't do that, they eat you up.
I
You went to a fancy French restaurant.
Like, don't you use that first, like the closest one?
You are major
All I know is
back
that
to you with
it's
a
fork.
hot and
it's like
panic
giving
goal.
you a dirty look.
All I know is the
Or
biggest
you trying to do
spoon.
it?
Exactly.
Super
So what the calculator is doing
All I know
is multiplying by a factor of 1 and giving you this. And it's telling you that was the factor that you multiplied it by to get rid of it. Okay? That's what the calculator does for you. Wonderful. It's your best friend.
These are the ones that-
Yes, ma'am.
So if they give you, like for the 45, 45, 90, they give you the 90, then that's when you divide it by.
Yep.
Just the ones that just leave us there.
Yep.
Root 2.
And same deal with the 60. If you have the 30, 60, 90, if you have the 30, 60, 90, you know you have the x root 3, and the 2x. If they even give you across from the 90 to the 30, 60, 90, let's say that was 22. It's not 2 times something, it's not 2 times the 22, it's 2 times what equaled the 22. And it's the same idea. You're trying to figure out what are these scale multipliers that give you these values. You can divide out by the 2. And you take it and substitute back up. Okay. That's, I try to bring it back into a setup like this for you guys because I know you guys can do a one-step equation. Okay. And I think a lot of times you overthink a little bit on this stuff and try to think that it's going to be more difficult than what it really is. Am I kind of right on that? Skeptical? Yeah. Well, not always it should be skeptical. I mean, sometimes. Yeah. Yeah.
Something like that.
No, and you're right, and that is a good thing to think of because eventually it does get a little bit more complicated when you start putting everything together. But we're still at a point where we're not ready to do that yet.
I can't wait for the day that the person will be.
I said got some big. It's got a big T.
I don't know if that's actually going to happen, but you never,
That might
you know.
happen because technology.
by whom.
Future.
I don't know who they are.
Any others than 7-4? Is there any other style of 7-4, 30-60s, or 45s you would like me to try and show you? Is there any other craziness? I don't want to take this one because this is a good sheet here.
What?
What?
So you're not coming.
So let's do this. I want to get back to
Oh yeah, my.
one other quick thing as we get into this. Unfortunately, I'm going to say this now. I will not be here for Flex today. Okay? Yes, ma'am. No, they'll still be Flex, but I won't be here. I mean, if you want to pop into another math teacher, grab a pass from your old math teacher, whatnot. But it won't be Flex tomorrow, but if you guys got a question, stop by in the morning. This is great if you guys got first hour. I have to let a contractor into my house to fix, we had roof damage, and the only time they could be there is at like 11:30 this morning. So I'm only going to be here for half the day today. So I apologize, I'm not going to be able to make that. Contractors generally don't like to work after 3 o'clock. If any of you guys know anybody in the trade businesses, it's pretty common. They're usually done pretty
Well, don't they have like a strict
double time. Yep, it starts charging you out a lot more. So.
Yeah, it's like 2 times an hour.
So that's why I want to make sure I go over a couple of these other trick ones. I don't say trick, but some of the other styles that I know that you guys had problems with in the past, and just to kind of reiterate some style stuff. So let's go back and look at, let's see, was it? Yeah, let's look at the ordered pair ones. Hey, can I steal your sheet? The ordered pair. The graph one. You have it on the both the graphics, the ordered pair?
The one with the graphs?
Yeah. Yes. It's that 72B. All right.
Got
the
it.
one that I don't have on in my computer, unfortunately.
You don't got?
I don't.
No, I'm gonna do a graph one, then I'll go to the other side again.
I just put this here to make it look like I read.
But you secretly read
No, I
aloud.
No,
in the shower.
I spark notice.
So, one of the
Speaking of
things that I
that,
know that you guys complained about with those graph ones is that the scale on some of the graphs was kind of crap. Okay? Now, what I'm going to do tomorrow, if I'm giving you something with a graph, is that I will have a 10 by 10 grid of graph paper, so it'll be easier for you guys to work with. So, with that being said, why don't you guys take a sheet of this, cut it in half so you can have, both of you guys can share one sheet of paper and we don't have to kill a tree for just one graph. You know what I'm saying?
Trees are
So just rip it down the middle so that way everybody has like half a sheet, just so you have a little piece of graph paper. Yeah, exactly. That way you guys can share it and have a piece of graph paper. Okay. And
I couldn't see him back there.
And let's take a second and use actual graph paper to plot this one and walk through the process again, okay? If you don't want to, I mean, I got plenty. It's not a big deal, you guys. So let's plot these. Come on, guys. Let's plot these ordered pairs real quick. -8, -4. -5, -2. -1, and -7. Okay?
Wait, are they going by twos?
No, these are all going by ones. Unless I didn't count wrong. No, I got it right. So, I know that you guys had complained that your graphs on the homework sheet were going by twos. When I give you stuff like this, I want to make sure it goes by ones because it's easier to count. Okay.
Yeah.
So what I've done here is I plotted my 3 points, and now what I'm going to do is just take this quadrant and put it on a separate sheet so I can blow it up a little bit so you guys can see it better. Okay. It was -8, -4, -5, -2, -1, -7. And like I said, I just screenshot it through, so put it on a separate sheet so it's a little bit, I can blow it up so for you guys to see. So in order to figure out what type of triangle this is, I want you guys to count your squares to use the Pythagorean theorem. Because what you're doing here is you're going to find these values of the hypotenuse going through. In order to do that, you're just going to count up 2 over 3, So this is a 2 by 3. Everybody see how this is creating a right triangle because of the gridding? So what I do is I'm going to say it's 2 squared plus 3 squared. It's going to equal that hypotenuse value squared. All right? What's up? You're welcome. It's not dumb. It's awesome. Sorry.
Merry Christmas.
So I get 4 plus 9, which is 13. And now I'm just going to take the square root of both sides. I'm not going to simplify it. I'm not going to worry about any of that. All I know is that that hypotenuse is the square root of 13. There's one of them. Okay? What's wrong? Okay. So I got the square root of 13 here. And I do the same thing for the next side. Here I'm going to go over 1 little, 2 little, 3 little spots, 4. And I go down. We go down, ready? 1 little, 2 little, 3 little spots, 4 little, 5
Oh, I
little
did.
spots.
I couldn't see. I can't see.
Oh, count your own then. So it's 4 by 5. It's not a 3, 4, 5 because the 5 would have to be the longest length. In this case, it is a leg, so it's not going to work. So we have a 4 squared plus a 5 squared. So it's 16 and 25. Last time I checked, I think that's 41. Oh, wrote it down. Okay. So that side length would be the square root of 41. Okay. And I do that one more time to figure out the last side length.
I think he's
And we count together.
Yeah.
1 little, 2 little, 3 little spots. 1 little, 2 little, 3 little spots. 4 little, 5 little, 6 little spots. 7.
What kind of line is that?
Who cares?
It's a bumpy line.
It's
like
either
a
you make
straight line
it
and
bumpy or you.
I
go
started
straight.
getting happy and I was singing and I was grooving and dancing and
Did you say you were grooving?
It's got bumps.
I was something. So
Holy
some bumps. Got bumps.
Yeah, you grooving like my
A
small.
line with bumps.
You groove.
So I have 3 squared and 7 squared.
9 plus 49.
9 plus 49.
58.
Oh my god. See.
So that side length will be the square root of 58. Again, I really don't care what it is simplified. It doesn't make a difference to us for right now. Now, of those 3 side lengths, which one of those would have to be the largest?
Square root 58.
Square root
That
of
one.
58. Very good. So now what you do is you check. Square root of 13 squared plus the square root of 41 squared. What's the relationship to the square root of 58 squared?
It's
Well,
It's
the square
bigger.
root of something squared is just the something.
I know. I'm saying
So
58 is bigger.
13 plus
That's what
41.
confuses me. It's like which one do you go off of? Sometimes.
So this is 54.
Don't all the.
Wait,
obtuse-
What's the square root of 58 squared?
Very good. It's obtuse.
Wait, don't, so the square and the square root just move out?
No. Yeah.
Now, be careful. If you had something in front of the radical, it wouldn't work like that. Okay? So that's why I don't simplify them. I just leave them with the square root symbols, because then if the square root of junk squared is just junk. Okay? So 54 is less than 58. And Twig, what was it then? It's obtuse. It's obtuse because it's obtuse because the value of c winds up being bigger. The c squared is bigger.
This makes a lot more sense.
I get that song stuck in my head.
All right. Now flip it over to the other side. You guys just love working with those things here. Steal yours real quick, Nick.
Oh, 15 and 20?
Yeah.
And they added some more.
That's like. Man, I want them skills. I do.
I want a water bottle right now.
I think
Ain't
it's 18.
happening.
Those are
Reiterated.
Well, actually, the ones in the halls over there are pretty good.
They ruined the TV show.
No, like, they're just
it's
yeah,
really
gross
crap.
because you have those gross
It
people
needs to
like
die.
I'm
So
not
when I got
gonna
home,
do
I was like, what am I doing here?
So in this one here,
it. And then-
it's giving you two side lengths, and it's asking you to figure out what does the value of x have to be in order to create it to become obtuse.
We did this one in class.
I know, I'm just re-emphasizing it. Fine, I'll switch it to acute, okay?
Woo,
I know,
fancy.
going on a limb. Okay. We're gonna do acute then. We're gonna change
Super
it.
adorable.
What?
So if it's going to be acute, that means the value of c squared would have to be smaller than the other two sides. Okay? So what happens is you write it out like this. It's x squared plus the quantity, x plus 3 squared, has to be greater than, because you want this side to be smaller, 15 squared. Okay? From here, I FOIL. Remember, when you have something squared, this means it's the something multiplied out, and then you have to FOIL. Okay, you have to do that. So, it is, it's Billy binomial.
Huh?
It's Billy binomial.
You just wrecked it.
Wait.
Great.
It's Billy binomial.
Wait, what is that?
It's a sentence.
It's Billy binomial.
It's not such
It looks like it has like a watermelon banana mouth or something.
That's like, yeah, it looks like
Hold on, hold on.
My Edward Central hands.
So you write it out twice.
Wait, that's what
You know
I
that movie with that like weird person guy thing?
Rainbow?
Yeah, that's what it looks like.
Yes. Oh, come on.
Wait, no, I needed that.
So then you multiply it out. Multiply it out. Guys, FOIL it out.
So weird. I never saw it.
Okay? So now all the stuff on the left-hand side, you want to combine all your like terms and simplify. At the same time, I'm going to subtract the 225 to the left because in order to solve this, I have to get the side to 0. And all I have to do left is 9 minus 225, and I believe it's negative 216.
Yes.
What's that? So now you're at the point where you can try to factor, or you can go ahead and jump right to your quadratic formula, or you can take a GCF out. Personally, as soon as I see 3 numbers that are even, I'm going to divide out by 2 because it doesn't make a difference in the problem. You're taking out the scalar multiplier. Everybody agree that all 3 of those numbers are even?
Yeah.
Yes.
Okay. If I take out a 2, I'm left with x squared, 3x, and this becomes 108.
Yes.
Now, first thing you do is try to factor it. What times what's negative 108? You add together to get 3. 12 and 9. Or jump to your quadratic formula. Okay? If you jump to the quadratic formula, remember that's your coefficient, so it's the opposite of b, plus or minus square root b squared minus 4ac, all over 2a. And when you wrote this out, you were going to get a positive value and a negative value. Can we have a negative value for a side length? No. So you have to set it. You set it up, and then you're going to disregard one of your values. So in doing this, if you use this, your a value is 1, because that's the coefficient here. Your b value is 3, and your c value is negative 108. So what's the opposite of 3?
Negative 3.
What's 3 squared?
9.
That's 4 times 1 times negative 108, all over 2 times 1. And I've said this many, many times. Do not try to put all that in your calculator. You'll screw it up. What I want you to do is just put this part in your calculator first and then rewrite the problem. When you do that, you get negative 3 plus or minus the square root of
432.
I don't know, use your calculator.
Minus 9, that's 400.
Get a number.
423.
If you're multiplying, you can't get
441.
How did I get 21?
And then you take the square root of it. All I'm doing is I'm not taking the square root quite yet. I'm just writing out what's underneath the radical first. Okay? So now what's the square root of 441? 1. So now you have this. You have negative 3 plus 21 over 2, or negative 3 minus 21 over 2. Which one of those two answers could you throw away?
The one on the right.
Correct. And why?
Because it's a negative.
Because it's negative. In this case, I could throw out the one on the right because it gives me a negative value. I cannot have negative values for side lengths. So you can eliminate that. This, no working. So what's negative 3 plus 21?
18. Yeah.
18 divided by 2 is? There's your answer.
How many problems?
You should explain this to people. On the
6.
internet. This is one. It's like
He doesn't know.
3, like 3 plus 3
Do
times
you watch the
18.
guy who like does it all on the
Okay.
computer?
That's how these things set themselves up. Okay? That's how these things set themselves up. Alright. I'm trying to think of any other goofy stuff here. What else you got?
Here's the problem.
Do you know one like that?
Yeah.
Here's what
Okay.
answer is.
What does it say? What does 20 say?
My answer.
X plus 2, X plus 3,
So that is 3 times 18.
29.
I'm actually gonna write this one.
I don't think that's 3 times 18. I think it's
Okay.
3 plus.
So if I do it this way,
I don't remember.
It's going to be another long one.
But one
it's the same basic as what we just did. It's just another FOIL problem, just to walk you through it again.
Minus, like, solid.
But those are double foil.
So you have x plus 2 quantity squared plus x plus 3 quantity squared. It's acute, which means the c squared value has to be smaller. So it's 29 squared. So I have to FOIL out twice. X plus 2, x plus 2, x plus 3, x plus 3. You get x squared,
That's 4.
2x, 2x, and a 4. X squared, 3x, 3x, and a 9,
2x squared
whatever this is squared.
plus
Ooh. Start combining all of your like terms. 2x squared, those go up. 2x, 2x, 3x, 3x, well that's
10x.
5 and 5, so it's 10x. 4 and 9 is 13. And then I'm going to subtract to bring that 29 squared over. What was 29 squared?
a big number.
Subtract 841. Okay. And now all that's left is to take 13 minus the 841 and we get some other number. Was it 828? Is that right? Hey, it is 828. Look at that.
Wow.
It's close enough. Now I have a side equal to 0 then. Or sorry, it's greater than 0.
That's right, 828.
Make my life easier. What can I do?
Divide by 2.
Take out a 2. Okay. And then I'm going to use the quadratic formula again because I don't know my factors of 414 that add together to get a positive 5.
That's how we got
Use your calculators. Yeah, use the quadratics. We have x, so it's the opposite of b, plus or minus square root, b squared minus 4ac.
Oh, yeah, I remember that.
Okay.
Mr. Judkins had a song.
Oh yeah, we all have songs.
Or
What's
just
the
song.
opposite of 5?
Never mind. Never mind. I know his song.
5 squared is 25. What's my value of a? 1, good. And then I have to multiply times negative 4, 14. And I divide everything by 2 times 1. So, again, I want you guys to get in the habit of just trying to figure out what's underneath the radical before you do anything else. Just make your lives easier. So it is 25 minus 4 times 1 times negative 414. And I get negative 1681. Not negative, excuse me, positive 1681. And now I got to figure out the square root of that. It's 41. Which one of those two can I throw away again?
Minus.
The negative. You can throw away the negative value because you can't have negative side lengths. So now it's just order of operations. Negative 5 plus 41, and then divide that by 2. And there you go. What I want you guys to work on tonight, I've got a couple more of these mixed problems as far as the 45, 45, 90 stuff is
A
concerned.
and B and C.
But I've got, we've done every one of these problems like this that's fine.
B and X.
X squared is A, X is B, and the regular number is C.
No.
Duh, I have it right here.
There's that too.
So on this 7-4 sheet, I want you guys to do 1 through 12 and 18 all. Okay? 1 through 12 and number 18.
How many parts are number 18?
How many parts? Just one.
What?
Wait, but, oh.
Are they going to be special triangles?
Yeah, this is all specials. Okay? These are all your specials again. Use your separate sheet of paper and write them out with your 30, 60, 90s, 45, 45, 90s. Makes your life easier. You have to trust me on this. Okay?
I still have
Mr. Murphy, what's your song? You just said all math teachers have songs.
Oh, it's just the regular x equals negative b plus or minus square root b squared minus 4ac all over 2a.
I thought it was that one middle two.
That was your song.
I had